Okay, so we're going to measure the pH of some household things. I'm going to use two methods to measure the pH. The first is the pH pen. Now this pH pen has an app on my iPad, and unfortunately it's just barely enough so I can read it. So I just want to measure the pH of all these household things. The first way I'm going to do it is with the pH pen. So I'll measure deionized water first because I'm going to use that to rinse. So I stick the pH pen in deionized water. Stopped at 5.89. Okay, I don't need to rinse this off. Next is going to be Windex, which is ammonia free. I just learned that it's ammonia free. So I'm going to stick my pH pen in here. And what I want you to do is record the data, and it stopped at 11.02. Did you realize that Windex is basic? Remember, basic is anything over 7. All right, let's go on to household vinegar. 2.76. Okay, what about just regular drinking water? So the drinking water ended up around 7.05. Okay, let's go to milk. Think milk's going to be acidic, basic, neutral. Kind of levels out at 6.8. So milk is slightly acidic. Got to rinse that off. What about orange juice? You know orange juice has citric acid in it. 4.08. Remember, the logarithmic scale is exponential, so a pH of 4 is 10 times more acidic than a pH of 5. Ooh, I have a cup of coffee here. Let's try coffee. 5.78. Okay, I cleaned my coffee pot with this material. Descaler kind of cleans out the scaly particles and deposits. Most likely, it's probably citric acid in powder form. You can order it from Amazon. 2.29. So you want an acid, but not too strong. You don't want to dissolve your coffee pot, but you want an acid to clean off those scales. Okay, vitamin C. Are you taking your vitamin C? Haven't heard if that works good against coronavirus. 4.99. Okay, got an aspirin tablet here. So I crushed up an aspirin, put it in water. You know what aspirin is? It's acetyl salicylic acid. That's what aspirin is. So it should be acidic. 3.15. Simple green. I always wondered about this one. Oh, it's basic. 8.96. Bleach. Bleach is going to come in at 10.64. My cameraman thinks I ought to write all these down for you. Forget it. You're writing these down yourself. I have some soda here, some Sprite. What do you think? So this is carbonated water, so it's carbon dioxide in the water, which forms carbonic acid, 3.59. So acidic. Okay, I have some isopropyl alcohol, rubbing alcohol, 5.55. Let's do, I have some wine. Ugh, I don't like that kind. $3.67. Okay, the last one that I'm going to use, I saved, got some shampoo, 6.4. Okay, now I told you there's two ways that we're going to use to measure the pH. So a pH pen gives you a fairly good number. pH pens were designed by a man named Beckman, and he had his lab over here in Fullerton, not far from my house. Okay, now the other way to measure pH is using a pH indicator. So I have this universal indicator, and it's really only going to be good in the ones in which we don't already have a color. So that's going to be challenging. I don't want to put in coffee, you won't be able to tell. So what I want you to do is, when I tell you what it is, you're going to come up with a pH scale for universal indicator. So here's vinegar. Remember, that was the acid. That's red. Here's Arrowhead water, green. Well, let's try the milk. Kind of yellow, you can see. Orange juice, probably we'll see. Oh, you can see the red forming. This was the Descaler. Here was the vitamin C. Simple green, I'm not even going to try. How about bleach? Not probably going to be bleached, but okay, here's the soda. Pretty. The alcohol. The shampoo. And did I skip the aspirin? Okay, here's the aspirin. All right, here's the deionized water. And this is the Windex. It's already kind of blue, so it's probably going to mask. But you can see a little bit that it's purple in the base. So acid, base, neutral. Now maybe right about now you're getting an upset stomach and you're just wondering if it's time for a commercial. So I have this antacid to help you with your upset stomach. And I wanted to put it into a graduated cylinder with universal indicator, just for fun. What's going to happen? What colors do you think it will form? This is one of the reasons why I love chemistry, because of the colors. So let's just plop in and see what happens. Ooh, look at that. Can you see the red, the pink, the orange, the yellow? Yep, it's going to bubble over. Now, why is it more towards the acid side than towards the base side? I hope there's nothing in this desk. So let me get rid of some of that. Yellow is more towards the acid side. Why did it do that? That's because it produced carbon dioxide, as that was the gas that was produced. And carbon dioxide actually reacts with water to form a weak acid. Now what would happen if I put some sodium hydroxide in there, just for fun? Look at that. I just love these colors. Look at. You can see how it's reacting as it reacts. You can see how it mixes. And what happens if I put a little bit of acid in here? You can see it's going back towards the pink, but then as it mixes with that base, I just love those beautiful colors.